Now we're ready to look at analyzing some data. And in statistics, we like to analyze data, look at it, find out some predictive values, try to find out trends. And one of the trends we want to look at is what is an average. And we actually have a number of ways to find an average. Averages will tell us where the center of data is. And the easiest way to find an average is to look at the mode, which value occurs most frequently. Sometimes you'll have more than one mode, a bimodal curve. Sometimes you won't have any mode. None of the numbers are more frequent than the others. Median, on the other hand, once we put all of our numbers in order and find the middle value, that middle value is our median, and that is an average as well. And the one that is probably most common for you to find, although the symbolism here doesn't look quite as common to write down, is the mean. The mean is the sum of all the numbers divided by the number of values that you had added up. So add them all up and divide by how many there are. Symbolically, if I had each number in my data set, if I called it an x sub 1, first number x sub 1, second number x sub 2, x sub 3, and so on all the way up to my last number of x sub n, I would want to add them all up, and then I would divide by how many there were, or multiply by 1 over n. And that's what this symbolism right here is showing. If I add up, there's my sigma notation, all the numbers having each of my values being called an x sub I, and so I let my I value, or my first subscript, start as 1 and continue until I get to my last subscript being n, and I want to add them all up, and that's what this sigma notation will do. And after I add these all up, then I would be multiplying by 1 over n, which is the same thing as dividing by n. And the symbol that we use for a sample mean is an x bar. So when we put a bar over a letter, that's going to signify us in statistics that you've just found a mean. And yes, we do call that symbol x bar. So all three of these are averages. Now, percentiles are also important values when we look at statistical measures. And if we're dealing with percentiles, let me just give an example. If I say something is at the 30th percentile, so here's just an example. If I have a 30th percentile, a 30th percentile is going to be a specific number. So a specific 30th percentile is a specific value. And what does the meaning of that value have? That meaning would be that 30% of the values or the scores in this distribution would be less than or equal to that value. So say you were in the 30th percentile for height, and your height is, say, 5'2". That would mean that 30% of people your age have heights that are less than or equal to your height. If you are at the 90th percentile, then 90% of people at your age group are less than or equal to your height. Some books will use strictly less than the value. Some will use less than or equal to the value. And we're going to use the idea of less than or equal to. That's what we use in AP statistics, so we'll just kind of be consistent with that. Now, quartiles are values that separate the data into 4 parts. And so you've made box plots in the past, and we're going to look at an example of a box plot here. So we'll go back up and look at that idea of what the quartiles are once we look at some numbers. So I have a list of 12 numbers here that are in numerical order, and we know how to find the median. We would go to the middle number, and my middle number, I happen to have an even set of numbers, so halfway between these two, or add these two together and divide by 2, I find out that my median value is 72.5. Then we want to find the quarter mark of the data, or half of the lower half, and that's going to be one of my quartiles. So I have 6 numbers that are below the median. And so I need to go halfway between, and that takes me to a number of 60.5. Add these two together and then divide by 2, and we would come to 60.5. And that's called our Q1. It's also called the lower quartile or Q1. Go up on the upper half and find halfway through. The upper half will take us 3/4 of the way through the data, and so halfway between 82 and 84 will be at 83. And so 83 will be my third quartile, also called the upper quartile. And so we have what we call a 5-number summary. That quite often you'll see that type of terminology being used in statistics. And when we have a set of data, we like to look at a 5-number summary if we're particularly going to be drawing a box plot. And the 5-number summary is going to be, what is your low? What is your high? What is the median? So halfway between those. And then halfway between these two, we have our first quartile. And halfway between these values, we have our third quartile. So that's what I would mean if I ask you to list down the 5-number summary. And this 5-number summary will help us draw our box plot. And so once we have identified these 5 numbers, then we go to a scale. Appropriately, our data had the lowest number be a 56, the highest number be 86. So this is scaled from 50 to 90. And I put a dot where I have my low. I put a dot where I have my high. And then I will make a box around where my Q1, my Q2, and my Q3 are. And then we know that all the data lies between these two values. We know that half of the data lies between these two values. We know a quarter of the data lies between these two values. And my data has been split up into 4 quarters. So I have a fourth of the data lies in here, a fourth of the data lies in here, a fourth lies in here, a fourth lies in here. So we can see that these values are all kind of closely knit together. These are a little more spread out, and it gives me a nice way of seeing the distribution of data. Now, a couple definitions. One is, what is an interquartile range? The acronym we use for that is IQR. And interquartile range is simply how wide the box is. So it is a range. It's the range of the middle 50%. So if I take this value of Q3, which in our data case happened to be 83, and subtract from it the 60.5, the width of this box is called the interquartile range. So the range would just be the difference between the high and the low, and the interquartile range is the difference between the third quartile and the first quartile, which gives us, again, the middle 50%. Now, sometimes we have values that seem to be kind of strange, or they're outliers, and we're going to have a specific technique for determining whether we have outliers. I'm just going to write down what the criterion is, and then we will look at an example and come back and look at the information. What we use is the 1.5 IQR test. And by that, what we end up doing is we really want to look at this, what we call the whisker, and see, is this whisker too long to be considered unusual, or is it kind of normal variability? And so we go to, first of all, we'll look at the upper outlier. If we take the third quartile and add on 1.5 interquartile ranges or box widths, anything that is higher than that would be considered an upper outlier. On the other hand, if we want to find out if we have anything at that low end that seems to be an oddball or an outlier, we take this Q1 value and subtract away 1.5 box widths or 1.5 interquartile ranges, and then any number that is below that value that we calculate would be considered a lower outlier. And once we look at an example, we'll see that it's really not too difficult to do. Okay. All right, so let's flip the page. Now I have a set of data here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And if I'm going to find the mean, we know for our mean we would just add them all up and divide by how many there are. So we would sum up all of the x sub i's from the first one to the last one, and we have 9 numbers, and then we would divide that sum by 9. And I did that, and that would again produce us our x bar, or our mean. And I did that, I had that the sum of the numbers came out to 747 divided by 9, so I got a mean of 83. So that's one way to find an average. Now to find my median, I would have to put these numbers in order first, and I can see they're not. And I have done that. Let me just slip another little sheet here. It's not going to show up quite as well. And in fact, we might turn the little light off and see if that helps a little bit. And so I have my values that I've listed in order. And once I listed these in order, I could do this as simple as this, go in and find that, the middle number is 80. Because I have an odd number of numbers, my median was going to be one of my values. So last thing to find, and we can see that these are different. They won't always be the same. Sometimes the mean and the median will be the same, but they definitely do not have to be. And my mode, I have one value that occurs twice. Everything else is a singleton, so I would have a mode of 78. Okay. Sometimes all three of these numbers are the same, but by, again, any means they do not have to be. Now, I have another set of data, and I want to go through and look at the percentile ranks. And all my numbers are not in order, so it's really convenient if they're given to me in order. And I can see that I have some numbers in the 20s. I go as high as 98. Hopefully these are not test scores. We wouldn't want to have 20s to 98s, but they are what they are. So the very first thing I did was I organized a stem plot, or a stem and leaf plot. And this is a very nice way of organizing my data. I saw my lowest value that I had, again, was a 20-something, and my highest value I had was 90-something. So I put the tens place along here, and then I went through and putting them in numerical order. I put down the ones places over here, so I can see a nice distribution, how the data is spread out. Now, we also want to put a little key, and I'm putting down one of my first elements that 2/1 is actually standing for a score of 21. So now I want to find the 30th and the 60th percentiles for these values. And so if we think about it, if we had listed all the numbers out in one big line, we want to go 30% of the way through the line and find out what that value is. Or for the 60%, let's say this is halfway through the list, if we want to find the 60th percentile, we want to go to the position that has 60% of the numbers less than or equal to that value. So what do we do to find that? First of all, I'm finding the 30th percentile. And I, again, counted this. I have 20 numbers in my list. And so since I have 20 numbers in my list, I need to go 30% of the way through that list. So 0.3 times 20 gives me 6. I need to go to the 6th number in the list. And so I counted and found out that that 6th number in my list is actually this value of 54. So 54 is the value that has 30% of the values less than or equal to it. Now likewise, if I want to find the 60th percentile, my 60th percentile, I have 20 numbers in my list. I want to go 60% of the way through the list. So I want to go to the 12th number in the list. And so I counted and I figured out where that value was. And I found out that this 71 has the position of having 60% of the scores are less than or equal to that value. Now, last thing we want to do is draw the box plot again and then check for outliers. So I have taken these numbers, and again, we had 20 numbers, and I know what the 30th and the 60th percentile, but that's not what I need for this discussion. So I do know what the low is. I do know what the high is. And now I had to find the median. And remember, if you have 20 numbers, the median is not going to necessarily be one of your values. It's going to be between two. 20 divided by 2 is 10. So I'm going to have 10 numbers down here, and I'm going to have 10 numbers up here. And I need to go and find the 10th number and the 11th number after they've been put in order, which they are in my little stem plot, and I need to find the mean of these two. So I did that. I counted, and I found that this 65 right here is the 10th number, and this 65 is the 11th number. So nicely for me, halfway between those two is 65. Now, I need to find this first quartile. There are 10 numbers who are positionally below the median. This number is a 65, this number is a 65. There are 10 numbers down here. 10 divided by 2 is 5, so I need to split this list in half. I need 5 numbers here, 5 numbers here. I have to find this 5th number, I have to find this 6th number, and I will have to find the mean of those two to find my first quartile. And so, again, I counted, and I found that the 5th number in my list was 47, and my 6th number in the list was 54. Add them together, divide by 2 to find the mean, and that number halfway between these two is 50.7. And likewise, I did the same thing at the opposite end. I have 10 numbers who are above the median. Split that in half. I should have 5 here and 5 here, so I counted from the end 5 numbers from the back and 6 numbers from the back, starting here again. And when I did that, I found that my 5th number from the back was this 93, and my 6th number is the 87, and halfway between those two, finding the mean, is 90. So I have my 5-number summary. Now, I plotted those, and I made my scaled consistently, and I put a dot where I had my low of 21, a dot where I had my high on the same horizontal line, and then I made a line down where I had my Q1 at 50.5, a line down where I have my Q3 at 90, and a line down where I have my median. Now, how wide I make this box is up to me, but when we make these whiskers, we want this line to have this horizontal line go through it and be half at the halfway point. So I make my little box. So now think about what this means. A quarter of the data lies between these numbers. A quarter of the data lies between these numbers. A quarter lies between here. A quarter lies between here. All the numbers lie between these two values. The middle half lie between here. The difference between these values is the interquartile range. So I had to find that, because we're now going to check for outliers. We want to know, is 21 considered a, quote, oddball compared to the other numbers, or an outlier, mathematically? Now, typically, we would just look at a score of 21, seeing that somebody else got 98, and think, wow, yeah, that's got to be an outlier. It all depends on how the data is spread out. So my first thing is to calculate the interquartile range. Secondly, I want to find, do I have the upper whisker and the lower whisker long enough to be considered outliers? And graphically, it looks like this. Basically, I take the width of the box, which is the interquartile range, and take 1.5 boxes. So there's a box width. There's about 1.5 box widths. If either of the whiskers is longer than that, we have an outlier. So we'll do our little double check. And this is the mathematical way to check. I'm finding the lower one first. I take the Q1, subtract away 1.5 box widths, or 1.5 interquartile ranges. And remember, what I'm really doing is saying, is that whisker longer than a box and a half? So I have my low number, or my Q1, minus 1.5 interquartile ranges. And when I do that calculation, I would have to have a number smaller than negative 8.75 to have an outlier. So no, that is not an outlier. On the upper end, I can definitely see that this is not going to have an outlier in the upper end. This whisker is not very long. And so if I have 80, I take the Q sub 3, which was my 90, and add on 1.5 box widths, I would have to have a number that was 149, basically 150, to end up being an outlier. So I don't have any outliers. And now you're ready to practice.